find the number of 7-digit numbers which are multiple of 11 and are formed using these 7 digits 1, 2, 3, 4, 5, 7 and 9. Now this is a very interesting problem, and in recent year in JEE Main there are few PYQ where you need number of numbers which are multiple of 11. So first of all, the condition for a number to be divisible by 11 is that sum of digit at odd place, sum of digit at even place, difference of those two is multiple of 11. For example, if I have this number 25927 and if I want to check whether this is multiple of 11 or not. So first find sum of digit at odd place. At odd place we have 2, then 9 and then 7. Sum of these three digits will be 9 plus another 9, that is 18. And at even place, you have other two digits, 5 and 2. Sum of these two digits will be 7. And now take difference of these two. If the difference is either 0 or multiple of 11, then the number is multiple of 11. For example, here O minus E will be 11, which is multiple of 11. Therefore, this number is also multiple of 11, right? So, here we need number of all 7-digit numbers which are formed using these 7 digits and they are multiple of 11. Now, let us say that the 7-digit number is n and we have A, B, C, D on even place and alpha, beta, gamma on odd place. So that means, or A, B, C, D on odd place, alpha, beta, gamma on even place. So A, alpha, B, beta, and then we have C, gamma, and then you have D. Let us say this is the 7-digit number that we have. O is representing sum of digit at odd place. So O will be A plus B plus C plus D. And E is representing sum of digit at even place. So E will be alpha plus beta plus gamma. Now here, if I calculate O plus E, then this will be nothing but sum of all these 7 digits. Right? First we'll see what are the digits that we can place at odd place and even places. So O plus E, this will be sum of all these 7 digits. If you add all these numbers, you will get 15 plus another 16, so it will be 31. So this must be sum of all the digits, right? Sum of digit at odd place plus sum of digit at even place. Also O minus E, if I want to make the number multiple of 11, then O minus E, that must be either 0 or multiple of 11. So O minus E will be either 0 or it will be 11 or it will be 22. We cannot have 33 because if sum is 31, difference cannot be more than 31. So these are the different possibility. Now again here, uh, if I add, let us consider the first possibility that O plus E is 31 and O minus E is 0. So if I add these two, 2 into O will become 31, which is odd number, right? So that means O will be 31 by 2, but O is representing sum of 4 digits. So therefore O cannot be fraction, right? And hence we cannot have this case, right? We cannot have O minus E as 0. Now using similar logic, you can show that O minus E, this cannot be 22 also, because if O minus E is 22 and O plus E is 31, then 2O will become odd number, which means O will be a fraction. So the only possibility is that O minus E must be 11. And now solve these two equations, right? So O plus E is 31, O minus E is 11. If you solve this one, you will get O as 2O will be 42, so that means O will be 21. And if O is 21, E must be 10. Right? Sum of digit at odd place 21, and which will imply that sum of digit at even place will be 10. This is one possibility. However, you can, instead of taking 11, you can take plus minus 11. Here we should ideally take modulus, but we'll interchange these two. So this will be one case. And another case will be that O is 10 and E is 21. In this case also the number will be multiple of 11. So now we need to consider these two different cases. One case where E is 10, E is sum of digit at even places, so that means alpha plus beta plus gamma. This is 10, this will be one case. And another case will be where O is 10, that means sum of digit at even places will be 10, right? So now we have to see that in how many ways we can select three numbers from there so that sum of those numbers is 10, right? So one possibility is that you can take 1, 2, and if I take 1 and 2, we got 3, we need another 7. So one possibility is that at even places, we can have 1 to 7 and remaining 4 digit at odd place. Another possibility will be instead of taking 1, 2, if I take 1, 3, we need 6, which is not there. Next, we can take 1, 4 and 1, 4, 5. So we can take another 5. So this will be next possibility. 1, 5 will be 6. So we cannot take any other number. Next one, we can start with 2. So if I take 2 and 3, that will be 5. Another 5 will make it 10. So 2, 3 and 5. This is another possibility. We have to pick 3 numbers from here so that their sum is 10. Right. So 2, 3 and then 5. If I take 2, 4, we need another 4, but we cannot repeat. So this will be the next case. Then 3, 4, 5 will be more than 10. Right? 3 plus 4 plus 5, that will be more than 10. So these are the only 3 cases that you can get. Right? These are the only 3 ways in which you can select 3 numbers from here so that their sum is 10. Now let us say n1 is the number of numbers in this case, which are multiple of 11. So n1 will be 3 cases we are getting, and in each case these 3 numbers we can arrange on 3 even places in 3 factorial number of ways, and remaining 4 digits you can arrange on 4 odd places in 4 factorial number of ways. So in this case you will get 3 into 3 factorial into 4 factorial. 3 factorial number of ways of arranging these 3 digits, 4 factorial number of ways of arranging other 4 digits, and 3 such cases we are getting. So this will be, after calculation, you will get 432 from here. So these are those numbers which are multiple of 11 and for which sum of digit at even place is 10. Now let us consider those cases where sum of digit at odd place is 10. That means a plus b plus c plus d. This one is 10. So now we need 4 numbers from that set, and sum of those 4 numbers, that should be 10. So clearly you can see that if I take the first 4 numbers 1, 2, 3 and 4, then only we can get a sum of 10, and we cannot have any other sum because in this case we are taking the 4 smallest number. So that means 1, 2, 3, 4 on odd place, remaining 3 digits on even place. So if n2 is the number of numbers in this case, n2 will be nothing but 3 factorial into 4 factorial. So 24 into 6, that will be 144. So in first case, we got 432 number. In second case, we'll get 144. And therefore, our final answer will be sum of these two. So 130, 144 plus 432, that will be 576. And therefore, that should be the correct answer for this problem. So in multiple of 11, this is the standard process that you need to follow. Find sum of all digits, that will be O plus E. And then O minus E, you have different cases. But for O minus E, we can take only odd value if O plus E is odd. Right? Ultimately, when you add these two, then 2O must be even. So if O minus E is either 0 or 22, this will not work. So only possibility is O minus E is 11, or minus 11 also will work. So for that, we have interchanged here. Right? So we got O as 21, E as 10, that is one case. Another one, 10 and 21. Now, in first case, alpha plus beta plus gamma 10. So we had to pick 3 numbers from here so that their sum is 10. We got these 3 cases. In each case, you can create 3 factorial into 4 factorial number of numbers. Right? These digit at even place, remaining 4 digit at odd place. So in first case, 432. Similarly, in second case, 144. And finally, after adding those two, you'll get 576, which is the correct answer for this problem.